What's up, data pipeliners? This is Data Engineer 1. You probably don't recognize me, but I swear this is definitely me. I had some free time today to get a haircut and shave my beard. So today's episode is really fun. What we're going to be doing is we're going to be walking through the transformation of a Jupyter Notebook into a Kedro pipeline. And so this comes as a special request from a friend of mine. Her name is Yetu, also known as the product manager of Kedro. And so, really quick, I just want to give a shout out. And she's actually in the running for Young Digital Leader of the Year. So, this website right here is actually just digileaders100.com. And you can vote for Yetu. If you think that Kedro has been fantastic, make sure you go to this website, click that vote button, just type in your name, your first name, last name, email, and then click on Yetu's name right here. And this is one of the best ways that you guys can support Kedro as an open source product. And the Quantum Black team has been so fantastic for sharing this product with the rest of us that I think it really is an opportunity for us to give back to them a little bit. And Yetu has been a cornerstone in that effort. Anyway, so that was just a quick mention of her. And so it was suggested that I actually do an episode where we transform a Jupyter notebook into a Kedro pipeline. And I think this is actually a very, very important task, right? So for starters, most data science pipelines start out as Jupyter notebooks, right? They always kind of start out as these Jupyter notebooks. They're a little bit of like messy, a little bit, kind of like difficult to wrap your head around. How do you transform some of these functions into Kedro or Kedroized pipelines? And today that's what we're going to be talking about. So I have a notebook here, and you guys might have seen it already. I kind of spilled the beans when I switched the tab on my browser here. But this notebook actually comes from Berkeley. So this is actually from the Berkeley Natural History Museum. So they have it right here on their GitHub page, BNHM/Jupyter. And so their Jupyter notebook here is about 2 years old or so, but I went through the notebook and it actually does seem like a pretty good place to start, and it still does work. And it's actually got a lot of fun little features in this notebook, and it's going to be great to take all those little bits and pieces and then turn that into an actual Kedro pipeline. So let's go ahead and take a look at the Jupyter notebook. So, of course, we start out with this huge amount of these import statements at the very top. Don't worry, we'll definitely take care of these guys. But at the very least, this is starting to look like a very familiar Jupyter notebook. And so we go down, and thankfully, I know that not many notebooks have this, but in this case, we do have a table of contents, and we do have like some descriptions, right? So the goal here, what this thing does, how we use it, etc. Now, the first part of this notebook we actually are going to skip over. It's basically just simple Python tutorials. But here is where we get into the more interesting parts. So we have this GBIF API. This is the Global Biodiversity Information Facility API, which seems like a super cool API. It's something that we can definitely use in the future. But they expose an API endpoint that allows you to get the occurrences of of data about different species in a particular year. And so here they have an example where they're looking for an occurrence of a species in a particular year. And so looking down here, they actually have a built-in library already. So this is the GBIF request library. If we scroll up, we can take a look at our import statements, and this probably comes from this scripts ESPM module. And so this is one of the built-in modules from the repository itself. So if we go into here, we go into scripts, we go to ESPM module, we can try to find, here it is, the GBIF request. And so here we have that request. It has this thing of fetching as well as getting pages. And honestly, this would be like a perfect candidate for us to use for Web API dataset. But in this case, what we're going to do is we're actually going to instead make a custom data set to wrap around this particular function. Um, that's because I do think that the web API dataset can be better put off as a separate video. And in this case, I want to cover how you would capture the different kinds of libraries that you might have inside of your Jupyter Notebook as modules for Kedro. And so in this case, we can see that because this is like a state modifying or like this external state touching aspect, effectively a impure node, what we want to do is we want to actually turn that into a data set for Kedro that we can start to transform. And so as we go down here, we can see that we have some parameters for the request, and then operations of the request itself. And so it has this rec.get pages. And then the records that come back, you can see here, are just this list of JSON objects. And so what you do is you pass in a particular scientific name, in this case, Argia agrioides. Sorry, I'm a data engineer, not a scientist. And in returns to us all of these parameters of this data on this particular species. Going down here, this is where it gets a little bit interesting. What they do is they take these JSON records and then turn those into data frames by using the pandas read JSON function. So it just dumps the JSON records into this pandas data frame. Of course, obviously, what you can do instead is just pass this records list directly into the pandas data frame, and that'll actually work since the pandas data frame supports having lists of dictionaries. But in this case, this is also a perfectly valid method to do it. And we'll probably do it in the same way for our case. And then going down, here's where it gets a little bit interesting. We have here this kind of like quick data analysis, right? So um, uh, you have some printouts, simple printouts of like schema and things like that, and then some like value counts, and then we start to get into these plots. What's really cool here, and something that I think that you should be taking a look at in your own notebooks that you have, is some of the reusable portions of the notebook. So in this case, for example, we have a really great set of plots that are related to that particular species that we pulled from our request data. Now, what's cool here is that what we can do is we could potentially create all of these lot outputs as nodes inside of a single pipeline. And not only that, we can make that pipeline reusable, meaning we should be able to pass in a single data frame into this pipeline and get out all of these plots. And as you can see here, like as we scroll down, one of the assignments calls for this exercise where you edit the code below and then like adapt some of the graphing cells above to explore your data. Instead of having to adapt our graphing cells above, we can just have a pipeline that we can reuse in order to generate all of the graphs and plots that we want to take a look at. And I think that's actually a very, very powerful feature that we can take advantage of Kedro. Now, scrolling down, I think this is also really cool. You have this Python library called Folium, which allows you to do a mapping. So it actually adds these like geospatial coordinates on top of like a simple map that you can use. What we're going to be doing also here in this video is we're going to be taking a look at the Folium documentation to make another custom data set. And this is, in a way, a little bit more of an advanced custom data set tutorial. And then finally, as we go through, depending on how much time, we may continue onward where we create some extra points and extra polygons for our data. I haven't actually run the rest of the notebook. I think probably stopping at this point here with the map is good enough for this video. And then maybe in the future, we can continue on with the rest of this Berkeley Natural History Museum notebook. So let's go ahead and get started with writing our Kedro pipeline. I've already prepared a Kedro new here, and it's all just inside of PyCharm. And I just did a very simple Kedro new, and then I created the BNHM Kedro pipeline. And so for this work, just to keep things simple for me, what we're going to do is we're also going to install Kedro Wings um, for this project. And that's because we're going to be creating a lot of data sets, and Kedro Wings just makes it much easier to generate those data sets for us. Okay, so while that's installing, let's go ahead and take a look at the very first part that we need to do. Well, of course, we need to also make sure that we mark our directory as sources root. And if you want a more in-depth tutorial on how you can set up your PyCharm to use Kedro, you can take a look at the video that I have available for that. So the first thing that we're going to do is we are going to wrap around this GBIF request object here in order to generate a new data set. So let's take a look at the parameters that we want to use, right? And it seems here what we want is the very simple parameter of, at the very least, the scientific name. So we want to make sure that we're able to put a scientific name through into the request using this rec.getPages. So getPages here is really the thing that we want to focus on. And this is going to be used for, what we're going to do is we're going to actually put this in the load portion of the custom data set. So let's go ahead into our project and let's create a new Python file. And this file is just going to be called IO, like this. And inside of this, we're going to create our custom GBIF request data set. And what it's going to do is it's going to extend the abstract data set and then overload those particular functions. In this case, because this data set is only going to be used for loading, we're going to actually ignore the save function. And so the way that we can do this is we can just simply raise a data set error and say this data set is read only. And so this way, if we ever try to write to that data set, we're going to get a data set error, and the error will say it's a read-only data set. The other thing that we're going to do is we're going to also add in those parameters that we wish to use. And in this case, the scientific name is one of the parameters that we want, and that's the one that we save here. Next, we describe the data set. Just for the sake of logging. And finally, this is where we get into the interesting part. We write the load function. Now for the load function itself, I want to use the GBIF request object, but of course we don't have access to it. So there's two ways that we can handle this. The first way is we can just go ahead into our PyCharm and simply set this scripts folder as a source root. So I'm going to right click here and then say this is source root. And now you can see that it's blue. This means that PyCharm will be aware of it in our path, and then we can import this GBIF requests from that script location. If you are not using PyCharm, what you would have to do instead is you'd have to configure your Python path variable in order to account for this scripts folder. Considering the size of this module, I think actually the easiest and most straightforward method is to simply copy it. So I'm going to unmark this as sources root. I'm just going to copy this request module and then paste it right inside of our own source BNHM. And here we can see we have all of the requirements fulfilled in terms of the imports. And when we go back to our IO, we should be able to hit Alt-Enter, and there it is. It says, would you like to import this particular module? And I'm going to say yes. Now, actually, instead of instantiating the module inside of the load function, I'm actually going to instantiate it inside of the data set. So it'll be self.rec. And so it's very similar to how we have it set up inside of our Jupyter Notebook. So now that we've got our request object all set up, we've got our scientific name, all we need to do is just basically copy and paste what we have here. So we're going to be grabbing the request get pages with the parameters, and the parameter here obviously is our simple scientific name, and this is again based off of the Notebooks API. So now we have our pages, right? So this is the set of pages. In this case, we want to, again, use the data frame. So we want to actually return the pages as a data frame as they do inside of this notebook. Of course, you could return it as a JSON object, but then you would require another node that sits outside of the data set to transform it into a data frame. And so we actually, since that's an obvious step that we want to do, we can go ahead and skip it and put it right inside of this load function. And there we have it, a new Kedro dataset that includes our GBIF request and returns our records as a scientific name. Now, at this point in time, I actually think it's advisable to go ahead and start a Jupyter Notebook using Kedro. We already have a Jupyter Notebook that exists that's open for us for the B and HM, but we actually don't have one specifically for Kedro. And the reason why I want to open this notebook is it allows us a very quick way to test whether or not our data set works. So let's go ahead and try to use the same parameters that we had before. So going back to the old notebook, the scientific name here is Argia agrioides, and what we're going to do is we're going to save that as a scientific name. And then we're also going to create a new instance of our brand new data set. And so the location for this data set is, of course, inside of our bnhm.io import gbif request data set. And here it is right here. And the reason why we can also do this kind of auto complete is because we're, again, using the Kedro Jupyter Notebook, and starting that up gives us access to the Kedro context as well as all the Kedro paths correctly set. So now we have our GBIF request data set. Let's go ahead and make that as a new data set. And then we're going to pass in the scientific name here, scientific name. So now we have DS, and now when we do a ds.load, we should get a data frame back. And it looks like we encountered an error, and we have an error where it says the object of type generator is not serializable. And this is because I actually missed a step here. So I sent the records object directly into JSON dumps. But you can see here inside of the notebook, we actually go through the paginated portions and extract the data that we wish. And so this was a mistake on my part, and that's okay. Mistakes happen. Let's go ahead and fix this. And so you can see the power of using the Kedro Jupyter Notebook is that it very quickly allowed me to see that we had an error. And not only that, Kedro Notebook also comes with a really cool little function, which is, I think, reload Kedro. And when we run this magic function, reload Kedro, we should be able to import the new version of this data set. So when we run this guy here, we can see that instead of having to restart the entire notebook, I just reloaded Kedro and then was able to get a new version of the data set. And so you can see this very quick pattern of iteration. You can go on this modifying your code within PyCharm, go back to your notebook, rerun the notebook, and you can immediately see the results of your work. And we have here the data frame that comes from the request data. If I do a df head, we have the data here, and the data looks pretty good. At the very least, it looks very similar to the previous set of data that we have here. So we're going to go ahead and wrap it up for today's video. In the next one, we'll continue on with this Jupyter Notebook where we start to break down each of the component pieces into nodes for our pipeline. And if this content is interesting to you, make sure you button that like, sub that subscribe, and ring that ding if you want to know when we're pipelining. And I'll catch you guys in the next one. Take care. Bye-bye.